All right, let's do section 9.4, page 471, exercise 29, which reads A, state why the integral is improper, and B, evaluate the integral or state that it diverges. For exercise 29, we have the integral from 0 to 1 of x, natural log of x, dx. Now we know that we have a problem because the natural log of 0 goes to infinity. So we have an infinite discontinuity at x equals 0, and that is why the integral is improper. And when we come across something like this, we need to rewrite the integral with a limit. So this is going to become the limit as b approaches 0 from the positive side, and it's from the positive side because we're looking at that interval between 0 and 1, and then we're going to have the integral from b to 1 of x, natural log of x, dx. And now we're ready to evaluate the integral. Now I think we'll need to use parts to do this. So we're going to let u be equal to the natural log of x, and we are going to let dv be equal to x dx. And this is a little unusual because usually we want to let u be equal to x, but you have to remember that whatever you let be equal to dv has to be something that you can integrate, and we don't know how to integrate natural log of x. So this tells us that du is going to be 1 over x dx, and that v is going to be x squared over 2. So now we can work on the integral. So we're going to have the limit as b goes to 0 from the positive side. And the first thing that we do when we're using integration by parts is write u times v. So that's going to give us x squared over 2 times the natural log of x, and we're going to evaluate that from b to 1. And then it's minus the integral from b to 1 of v du, which is going to give us x squared over 2 times 1 over x dx. And we can cancel out some of the x's there. And then what we have here is the integral from b to 1 of x over 2 dx. And we know what the antiderivative of that is. So we're going to have the limit as b goes to 0 from the positive side of x squared over 2 natural log of x evaluated from b to 1 minus x squared over 4 evaluated from b to 1. And now we're ready to substitute in for our limits of integration. So I still have my limit as b goes to 0 from the positive side. And this is going to give me 1/2 times the natural log of 1 minus b squared over 2 times the natural log of b minus, and I'm going to bring the 1/4 out, it'll be 1 squared minus b squared. And now we're ready to substitute in for b. Well, first of all, this term here is going to be equal to 0 because the natural log of 1 is equal to 0. And now when we substitute in for b approaching 0, this whole term is going to go to 0 as well because of the b squared in front. This is going to go to 0 as well, and it's going to leave me with -1/4.